Today, we're talking about our guest's journey from high-performance racing sailboats and aerospace technology to creating a vision to transform nautical transportation. So stay tuned. We have with us David Tyler, co-founder and managing director, North America of Artemis Technologies, who's working to bring sustainable, future-proof mass transit to our waterways. We're going to talk about how they are building new technology for fast, efficient electric aquatic vehicles, which can help solve the mass travel challenges of urban settings by prioritizing waterways, while at the same time enhancing tourism and the consumer experience. So let's talk to David about what they are doing. Welcome, David.
Hi, Chris. Great to be here.
Thanks for being on. This is your background is so interesting, and some of the technology and things that you're bringing to the game here are really interesting. So I'm excited to have this conversation. But before we get too far into it, you have a really interesting story. I mean, you've done a lot of, especially in the water, the aquatic nautical space, you've done some really interesting things, and you've had some really interesting projects that you've worked on. Could you kind of just talk about your story and your journey and how you got here to Artemis?
Well, I studied a law degree at university, the University of Birmingham in the UK, and I was kind of progressing down that path to go off to be a lawyer. But then I started working at a company called IMG, which is an international sports management agency. And I was always kind of fascinated with sport. I loved playing sport. I played field hockey for England as a kid. So it always, playing sport had always excited me. And so I worked in a couple of sports marketing agencies. And then just as I'd kind of finished my training to be a lawyer, I decided to set up my own talent management business and just go out on my own. I think I was about 26 years old. And one of the first people that I sort of started to represent was Ian Percy and his Olympic training partner, Andrew Simpson. And so I worked with Ian and Andrew to help them win their Olympic campaign in Beijing.
Can you talk a little bit about who Ian Percy is and what he did?
Yeah, so Ian Percy is a double Olympic gold medalist and silver medalist for Great Britain. So he's a well-renowned sailor, has competed in multiple America's Cups. And it was actually after the London 2012 Olympics, Ian and Andrew were invited to go out and join the Artemis Racing America's Cup Challenge in San Francisco. And it was a really exciting opportunity for them both to go out and do that. And actually, there was a bit of a tragic incident in that Andrew Simpson was actually lost his life in a training accident in San Francisco in 2013. Good close friend of mine, and obviously Ian's best mate as well. So it was a really difficult time. And we actually set up the Andrew Simpson Foundation in his name to provide a charity based in the UK to give opportunity to kids to get out on the water. It's something that Andrew was really passionate about. And it was at that moment when Ian was asked to take over that team, and he invited me to come out and actually be the commercial director for the racing team. So I moved out to San Francisco in 2013 to support Ian for the campaign for the 34th America's Cup in Bermuda. And that was, for me, it was amazing to be part of that team. Ian he's a great leader, really builds an amazing culture within the group, incredibly determined guy. And we had a fantastic campaign, came pretty close to beating Team New Zealand in their Challenger playoffs. But during that campaign, sailing had really kind of jumped forward in terms of technology. We were racing these hydrofoiling AC-50 boats, going 4 times the speed of the wind, operating at about 60 miles an hour. So they're incredible machines. And we kind of really knew that technology could have a wider impact within wider maritime space than just trying to win a boat race. And while Ian and the other sailors were on board the boat, I was often in these chase boats, these ribs that were flying around at at 40 knots trying to keep up with the sailboats. The guys on board would come off the water, on the sailboat saying, oh, that was not too bad day, was it? It was quite nice out there. And we'd be getting like slammed around, bounced around, engines rumbling, diesel fumes and all that. And we were kind of like, wow, there must be something in this foiling thing. And I think that was around 2017. And it was the same time that the International Maritime Organization had got 198 countries to commit to reducing their maritime emissions by 50%. And the world was kind of recognizing that climate change is a thing. We have to do something. Right. And so really with Ian's leadership, with myself and a number of the senior engineers from the racing team, we spun the company out of the race team, based ourselves at the University of Cambridge in the UK, and set off looking at ways that we could bring this amazing technology from the America's Cup into the commercial maritime space.
You've dabbled also into the aerospace side of things too. Could you speak a little bit about that?
What we're doing is really bringing together with our e-foiler technology, with what we're doing now at Artemis, is combining technologies from the yacht racing with electrification technology from the automotive sector, but also really utilizing, manufacturing and technologies from the aerospace world too. Our e-foiler vessels are made with lightweight carbon fiber to be as strong and light as possible. The boats themselves, they have a closed loop autonomous flight control system as well, so really easy for the operator to use. The boat will kind of take off by itself, maintain ride height, flying above the waves, and those kind of complex controls. Complex control systems and the use of kind of ailerons or flaps on the foils themselves, that technology has really come from aerospace business.
Yeah. Well, so, I just want to step back for a second and talk about sort of the America's Cup class racers. I mean, you worked on AC50s. I think they're AC75s these days. But for people who aren't familiar with the world of sailing and how much it's changed recently, can you talk about how the foilers work and what foilers are and what they do and how they've sort of transformed the industry? I mean, we just came off of the Vendée Globe, which is a favorite of mine, and this year the foilers, Charlie Dolan won it, and he was way out in front of everybody else. The foilers definitely clearly had an advantage over more of the traditional monohull boats. So can you talk about sort of how the foilers have impacted all of that and why they're so important?
A hydrofoiling boat has a foil, we call it, underneath the vessel, which is effectively like a wing, like an airplane wing under the water. So when a boat accelerates, it creates lift, picks a boat up out of the water, and that significantly reduces the hydrodynamic drag of the vessel, so increases the efficiency. So it means that these boats can go significantly further using the same power input, whether that's through sailing, the power of the wind on the sailboats, or in our case, the power driven by our electric motors within the foil themselves. Because you're flying out of the water as well, it means that you're not interacting with the waves as much because you have less surface area. So it means that the boats are incredibly maneuverable, in particular at high speed.
For people who've watched some of the racing that's gone on, I mean, there's been some really spectacular, scenes out there. Those boats are very, they're on these, wings that are sort of very thin, super lightweight, just sort of at the edge of performance, right? But what you're bringing is adapting some of that to a more street legal version of that technology, right?
Yeah, I think in the America's Cup, you're developing something. It's all focused on performance, on winning that boat race. So you want to create something that's incredibly efficient and incredibly fast. But particularly in the America's Cup, if you want to create something that's very fast, you have limited surface area, so you have smaller foils, but that means you have less stability. And then those boats can become really difficult to control. And you might have seen, if you're racing in those hydrofoiling classes, as soon as you come off the foils, you slow down significantly. And in the America's Cup, you come off the foils, and that could be the end of the race for you. So it's kind of that balance, that trade-off between high speed, maneuver capability, but making sure that you stay on the foils and don't drop down. With our e-foiler technology, with Artemis and what we're doing today, we're utilizing those principles of foiling to increase efficiency and effectively use foiling to increase the range of electric vessels, along with other benefits like improved ride comfort because you're flying waterways and reduce weight, so we can avoid speed restrictions in local harbours. But really, our approach to the development of our e-foiler system is to make something that is incredibly robust, reliable, and most importantly, meets the requirements of the regulatory authorities as well.
Tell me, like, about how you went from the America's Cup technology, which is incredible, and came up with the idea for Artemis and how you're going to sort of change transportation in cities.
Well, I think it's really difficult to decarbonize boats compared to trucks and cars. Water is 800 times denser than air, so the power required to move boats through the water, particularly at high speed, is tough. There's a lot of energy. Simply putting batteries into current vessel designs today means that they are significantly affected by either reduction in the range to have a viable transport solution, or significantly impacted in terms of the speed at which they're able to operate. So what we wanted to do was bring our foiling technology into maritime transport to effectively increase the efficiency of these vessels through that drag reduction and deliver viable range for commercial operations. So whether that is a fast ferry here in New York, where I'm based now, or a pilot boat operating in the port of Singapore, we really unlock the potential for kind of commercially viable electrification of high-speed boats.
When we talk about the market for this, I mean, there's certainly the United States has an enormous amount of coastline, as do many other countries, and a lot of inland waterways as well, and most of our large cities are centered around waterways. Can you talk to like what the market is and what the potential impact of this could be?
We're kind of finding out more and more all the time. The US in particular is a very important market. The thing about maritime emissions is that I think maritime emissions globally account for 3% of all CO2, but I think 15% are sort of NOx and SOx emissions as well, which are very dangerous emissions, and particularly maritime diesel. When it burns, it produces a lot of particulate matter, which can cause significant health problems. So for cities like New York or San Francisco in the US, or Seattle, where there's lots of kind of maritime transport and lots of ferries in particular, the pollution from those boats is a major issue, and that's why there's this huge opportunity for us, is really to support or reduce the emissions being created by those valuable transit options within those cities. I think one thing that a lot of places are recognizing as well is that historically the waterways were the highways. Whether it's in London, the Thames used to be the beating heart of London, and everything sort of moved on the water, and the same in New York as well. And I think with the invention of the motor car and obviously development with land-based transport and trains and things like that, we've kind of moved away from using those waterways. But actually, there's a big drive to kind of go back to the future in that regard. In New York itself, NYC Ferry, that is operated by NYC Economic Development Corporation, they had 0 ferries in 2016, and now they've got a fleet of 38 connecting Brooklyn with Manhattan, up to the Bronx, down to Staten Island as well. In San Francisco, they're looking to triple the size of their fleet, just because as kind of road and rail networks become busier and busier, congestion just keeps growing and growing. These cities are really looking to see how they can use waterway transport to really provide additional capacity. And frankly, it's far cheaper to bring in a new ferry service and try and build a new bridge or put in new roads or new rail networks.
Yeah. I mean, I guess the road is already there essentially with the water.
Yeah, and I think it's an interesting case around economics because I think people think, oh, a ferry is probably more expensive than a bus. But with the ferry, as you say, the road's already there. You're not paying for the road and for all the other sort of infrastructure that's required for that bus or that lorry to operate. And I think it's something that people kind of forget about.
Yeah, you don't have to create bus lanes for a boat.
No.
Let's talk a little bit about what these boats look like and how they're built and like just the size of them and like what they can transport, how far they can go, how fast they go. Can you speak a little bit to that?
Yeah, well, you can see one of them, I think, behind me. So
Yeah.
that's our EF-24, so our 24-meter catamaran. So that's a 150 passenger ferry. Um, it would we've got the first three of those in build at the moment in Europe and looking to kick off building those in the US later this year. So that boat is really perfectly sized for inner city commuter transport. So um, but also providing lifeline services to islands as well. So we're delivering one of our ferries to the Orkney Islands up at the top of Scotland. So I don't know if you know much about the Orkneys, but it's a group of 99 islands.
Oh, wow.
And so their ferry services really are critical. They provide obviously a way for people to get to and from the mainland to connect with each other, but also to provide the food they eat, the goods that they need, and also to provide, on occasion, some kind of the medical services that they require as well. So the ferry services in places like that are really, really critical. So we're really excited to be working with Orkney to help them decarbonize those operations by providing two of our boats. So we have a 24-meter platform that can deliver 150 passengers as a ferry option, but then we also have a crew transfer vessel variant of that boat too to service offshore wind farms. And then we have a much smaller EF-12, so a 12-meter monohull class of boat. And within the EF-12 range, we can deliver an application for pilot boats, also for offshore wind operations, a crew transfer vessel, and then water taxis too. And we kind of call it a platform approach to technology. So within the EF-12, we have kind of a standard foil system propulsion unit forward. We have the same power electronics, the same battery system, and then the option for single or twin propulsion. So you can also have a propulsion unit on the rudder as required. But from the kind of deck up, we can change the superstructure of the boat depending on the requirements of the application. So the pilot boat and the water taxi, they will have the same technology, but they will look quite different because of the user requirements.
These are all electric boats, right? And my understanding is they, like typically they do around like 25 knots, which is actually pretty fast. And I would imagine since it's riding above the waves, it's a much more comfortable ride at that speed too. I would have to imagine. And you get about 70 nautical miles. Is that sort of where your range is right now?
The 150 passenger ferry has a top speed of around 36 knots,
Oh, okay.
And then can comfortably cruise 70 nautical miles at 25 knots. The EF-12 range, the range of those boats is typically around 50 nautical miles at 25 knots and a top speed of just over 30 knots. But as you say, it's not about just creating zero emissions in operation. These boats have additional benefits. Reduced accelerations is significant as well. So because the boats fly over the water, you don't get that kind of slamming
right.
that a lot of vessels get particularly when they're operating offshore in bigger sea states. Because the boat cuts through the water, it creates very minimal disturbance or minimal wake. So it means that we can actually operate in places where at high speed in places where there's speed restrictions. So in Belfast Harbour, where we're based, there's a 6 knot speed limit there, but we have permission to operate at 25 knots just because one of the maneuverability of the boat, but two, just because we're not creating this kind of water wash or wave that can damage shorelines and can actually be quite dangerous to other water people on the water.
Can you speak a little bit to the complications of building something like this? Because it's not a small feat. Because one, if a car catches on fire with a because of a battery or something, you just step aside and wait for the fire trucks to show up. But if you're on the water, that presents a significantly different challenge. So your safety requirements are higher. Some of the challenges of dealing with that stuff are bigger. So it requires some really innovative technology, right?
Yeah, absolutely. And safety is a big priority, and it's critically important on boats. As you say, when you're driving in your car, if there's an issue, you can get out of the car and you can walk away. But if you're operating on a boat and you're in the water, it can be quite difficult. So there has been strong leadership from the flag states like the Maritime and Coast Guard Agency in the UK and the US Coast Guard in the US, working pretty closely with the maritime class societies like the DNV and Lloyd's Register, American Bureau of Shipping, RENA, etc., to develop rules around the electrification of boats, and particularly around the use of batteries on board boats. We actually have developed our own battery system for our vessels because we wanted to create something that was as lightweight as possible, because our boats effectively take off and fly. So by reducing the weight of our batteries and increasing the energy density means that we can go further and faster. So that was important for us. But frankly, we had a lot of guys that we brought in from the automotive space that worked on electric vehicles and electric drive units and battery systems, and they weren't probably as happy with the level of safety within maybe some of the maritime technology and maritime batteries, and felt that there was a different way forward. So we created our own standard 103 kilowatt hour pack that has all the fire suppression equipment within the box itself. And those packs have gone through the type approval testing process, which is pretty significant. You basically have to set cells into a thermal runaway, so create an event within the cell, within one module within the pack, and then the modules either side can't go above 90 degrees for 24 hours. So effectively, you're suppressing that event from happening, which will enable one, for people to get off the boat and to move to safety, but two, it also means that the rest of the boat can operate, and we can isolate that pack until you have the opportunity to remove it.
It sounds like a technology that would be welcome in the automotive side too. After seeing some of the things that have happened, recently.
Yeah, and I think we take safety incredibly seriously. It's something I think something that myself and particularly Ian is obviously really passionate about, and given the history and things that I spoke about earlier, making sure that everyone is safe is of paramount importance to us.
You mentioned like the one platform you got behind you will do like 150. How do you compare that to like a bus in terms of just sort of costs and capacity to move people?
I think 150 passenger ferry is more expensive than a bus, or we say a bus is 30 to 60 people. It is more expensive. But I think when we're looking
at that's like 3 buses.
It's like 3 buses, yeah. And so when we were kind of developing this technology, we certainly didn't want to create something that didn't make commercial sense. So we didn't want to create like a Concorde, where it was an amazing piece of technology, but the practicalities meant it wasn't a success. I think there's no point creating something that nobody wants or nobody can use, because that's pointless. So we spent a lot of time in analyzing the economics of the technology and the vessels for operation. And the exciting thing about our boats is because we're using significantly less energy than a traditional high-speed cat, our fuel costs are significantly lower. So just to, I guess, put it into perspective, in flat water, our ferry at 35 knots will be over 70% more efficient than a diesel standard vessel. But once you start to see a sea state, then that differential increases because we're still flying above those waves, whereas a normal boat's getting effective more and more because the drag is increasing as you're hitting those waves. And just in 1 meter significant wave height, that efficiency jumps from the 70s to the 80s.
Yeah.
So on a route in New York, for example, here, operating say from Wall Street down to Rockaway, replacing the current vessel with our e-foiler ferry would save over $2 million a year just on the operational cost.
That's not nothing,
No.
as they say. And I imagine too, just the longevity of these boats. Boats tend to last a lot longer with proper maintenance than like other types of vehicles on the road. So I got to imagine there's some nice efficiencies in sort of the long-term picture for a lot of this.
Yeah, and carbon composite boats last a very, very long time. Over 40 years. There's no rust on a carbon
Right.
fiber boat. And with the electrical system, there's far less mechanical bits on board the boat. It's very much like an electric car. There's less to do, frankly, from a service and operations perspective. So, in terms of sort of driving down costs, increasing efficiency, reducing the number of days that the vessel isn't operating, the kind of move to the electrical system really does support that. And with our offer, we're not only reducing those fuel costs because we're so efficient, we're significantly reducing the operation or the service and maintenance costs over the lifetime.
The infrastructure that you need for the charging infrastructure and all that stuff, can you speak a little bit to how all that works?
It's relatively straightforward, actually, for us. With the EF12 range, we use a CCS2 connector, so the same charger that you would use for your electric vehicle. We have a system that can charge at 320 kilowatts in just one cable. You just have a dispenser on the pontoon, and it means that we can charge our EF12 boats in around an hour using that system. We can also have a scalable shore-based energy storage system. So basically that provides a buffer. So where you have challenges around getting energy from the grid, you can have this effectively a battery in a box on shore. You can do a very slow trickle charge, particularly buying energy when it's cheap. Charge up that battery, and then it means that when the boat comes in, you have enough stored energy to be able to do a really fast charge into the vessel itself. And then with the larger ferries, there's kind of two options. You can have multiple CCS2 connectors to charge the boat, depending on your operational requirements. And then we're looking to utilize the MCS standard charger that will be able to charge up to 2.9 megawatts, meaning that we'd be able to charge the ferry in an hour using that one cable as well in the future. So
wow.
We're really, it's an example of how we're leveraging technology from that automotive space and bringing it into the maritime sector.
Well, and there's a lot of infrastructure, heavy infrastructure around ports too. So I imagine, this is something that can be deployed fairly easily.
I think for our size vessels, it's relatively straightforward. I mean, putting in our charging system in Belfast, our first one, the whole thing was done in 4 weeks, including the groundworks. And really, all we needed was like a 3-phase connection into that energy storage system on shore. So it was really easy to put that system in, no problems at all. And that's one of the benefits about our boats when you start to look at the ferry as well. The actual reduction in the required charging compared to putting in a standard vessel, an electric displacement boat, because we're so much more efficient. We need less charging infrastructure, so it can really reduce the cost of sort of that transition to electric vessels. But just on that point as well, because we're up to 5 times less energy operating at high speed, it means that our batteries last longer too. So when you're looking at total cost of ownership of the diesel boat versus an electric displacement boat versus our vessel, we're cheaper than in the diesel, say potentially by $2 million a year in terms of fuel. But when you start looking at the cost of replacement batteries on an electric displacement vessel versus ours, over 15 years we've seen savings of almost $70 million just on the cost of replacement batteries.
Wow.
So it's almost like a little bit of a hidden cost for people. That
are you investigating other types of technologies too, like maybe swapping batteries and hydrogen and things like that?
We have a technology roadmap to make sure that we are utilizing the best solutions there. And our kind of the e-foiler system itself is agnostic to the fuel source. We have an electric motor. We do need a battery because the energy needs to come from the battery into the motor, but we can either have a big bank of batteries and just have a full electric boat, or we can have a hydrogen fuel cell. And there's also other hybrid solutions for other applications like like Coast Guard or people that really need to have more range. Well, the thing with hydrogen, I think, is that the cost of the fuel is so expensive that the business case isn't as strong at the moment.
Right.
Whereas with the kind of the complete electric e-foiler ferry, we're cheaper than the diesel. If you use a hydrogen fuel cell, you're actually more expensive than the diesel. And I think once the cost of clean hydrogen comes down, once it's more available, then that business case will change. But I think the most efficient thing to do, particularly if we're operating in the UK, is to take that energy straight from the wind turbine and put it straight into the boat with minimal losses. I think that conversion into hydrogen to store, I think you lose almost 70% of the energy anyway, just in that conversion.
Yeah, it's like you could start building your own offshore wind farms and make that your charging ports.
Well, with the offshore wind operations, that is something we're actually doing. So
Oh,
we're
wow.
working with partners to be able to charge directly from the turbine. So when the crew transfer boat comes on, it drops off the technicians, and then generally they stay out in the wind farm for up to 4 hours, kind of idling around, waiting for the guys to finish their job. So there's an opportunity there to actually, tie on to the wind turbine and actually charge directly from the power being generated offshore, and then you have plenty of energy to be able to pick the guys up and then bring them home.
That's pretty cool. That's pretty cool.
Yeah.
Well, I would imagine also, a lot of what you're building has implications for other markets too. I mean, it's not just like you're developing tech just for yourself here. There's a lot of what you're developing could be applied to other markets. I mean, we've already talked about improve battery safety to the automotive market, but I mean, it sounds like there's a lot of other potential use cases.
Within the maritime space in particular, our battery systems don't have to be just enough oiling boats. They could be the energy storage system for sort of floating vessels or tourist vessels that operate slowly in ports and harbours. The same with the propulsion unit that we developed as well. That could be a pod drive for other maritime operations. And then we're also developing a collision avoidance system too. That's kind of a sensor fusion of sonar with camera technology connected with radar and AIS. Really important for us, given we operate at 35 knots and kind of potentially future moves to fully autonomous operations. We're going to need that in place. But that collision avoidance system could be used by non-foiling craft too, to make on-water operations safer and safer. And particularly if we're moving in this direction to get more boats on the water, then safe operations is going to become more and more critical.
Well, and I know collision avoidance is a big deal on the water. I know that a lot of ships now carry like radar early detection systems and things like that. And I know like when you look at some of these races, especially like the single-handed races, it's always like they're always hitting something in the water at some point. There's a lot of weird stuff floating around out there.
Yeah, and we've operated our boats in London, in Port of Antwerp. We were in Barcelona for a number of months in the America's Cup. We've taken our first vessels, Pioneer, our first vessel from Ireland across to Scotland a couple of times, so crossing the Irish Sea. We've certainly hit things, but we haven't had any noticeable damage to the foils because they have been designed to be robust, reliable, mainly kind of cosmetic things that can be fixed with a bit of a roller of anti-foul. But I know in places like Seattle, in Vancouver, they often have big, large deadheads, they call them, so big trees effectively that are kind of hiding semi-submerged under the water, and also whales and big mammals under the water that can kind of come up pretty quickly and breach that surface. So it's something that we know is going to be really important in certain locations, and we want to do our best to avoid hitting things.
So tell me, like, what's next for Artemis? Where do you go from here?
It's a big year for us. We started series production of our EF-12 boats last year, so those first few vessels are going out to customers as we speak. We have the first 3 ferries in build, so we'll be launching that first 150 passenger ferry later this year. So that will be quite a spaceship when it hits the water. To put it in perspective, our EF-12 boats are about 9 tons. That ferry is about 60 tons.
Wow!
So a significantly bigger beast. So really, I'm really excited to see that one hit the water first. We're going to be launching.
I want to see 9 tons just floating above the water.
Yeah. And then we have our first pilot boat going to be on the water later this summer. We're going to be demonstrating our first crew transfer boat with Ørsted at their wind farm in Barrow in a couple of months' time. We've just announced an MOU with a company called Delta Marine to start manufacturing Jones Act compliant boats in Washington State. So there's lots happening, lots going on. And I guess we as a business, we're 7 years old now, so not that young anymore. We're moving out of this kind of heavily focused R&D phase into this commercialization phase and kind of getting products out to people. And that brings its own challenges around customer service, after sales, service and maintenance, warranty, all of those things. So that's kind of that, and scaling our manufacturing as well, not just in Belfast, but across the world.
There's a lot to building a company, for sure.
Yeah, and we've got a really strong team. We've got a good group of advisors as well helping us, because it's, as a group, we certainly know we don't have all the answers, so we're certainly getting help where we need it.
Your boats are being built in Belfast, is that correct?
Yes, yeah. So a number of the boats are being built in Belfast, and then we have a wider European manufacturing supply chain as well, really to enable us to scale and deliver more boats to people. And so within the US, we will be manufacturing the boats East Coast and West Coast.
Belfast has such a shipbuilding tradition and a maritime sort of history there.
We were the first company to build a boat in Belfast for I think over 20 years when we arrived there, and it's been a great place to establish our HQ and our UK operations. Belfast has a really famous heritage with Harland and Wolff there, and the ships, the Titanic, but there are also lots of other great ships that were manufactured out of Belfast. And today there's an amazing advanced manufacturing supply chain, really focused around formerly Bombardier, now Spirit Aerosystems, where they build the wings for Airbus craft. And there's a lot of advanced composite manufacturers building bits for London buses and a lot of the automotive manufacturers too. So there's a lot of local composite expertise, a lot of great technicians, and really good local universities, both Ulster University and Queen's University Belfast. There's some really smart people there, and we're certainly leveraging those capabilities locally.
Well, I am really excited to hopefully get on one of these one day, and find a ferry and just enjoy that ride, especially on the really big ones. I think that just sounds super cool. So I just want to say good luck to you with everything you're doing. It's a really interesting story, interesting tech, and I think just on the entertainment and tourism side of things, I think it would be great for any city. I mean, I'm in Chicago. We've got a whole water taxi system. I've got a lot of good waterways here. I'm eager to see them here in Chicago. So as soon as you can get here.
Yeah, well, I think we were in Savannah here demonstrating to a lot of the big ferry operators in the US, and I was actually on a call with one of them, one of the guys that's worked in the business for a long time, and we were on a group call with lots of other people, and I said, well, what did you think of it? And he said, it was boring. I think that was the best compliment he could have given us, because there was no vibration, there was no diesel fumes, there was no noise from the engines whirling away. It was just silent, quiet, and enjoyable.
Those diesel fumes are awful.
Yeah.
Something about it, I just doesn't sit right with me anytime I'm on a big diesel boat. Well, thanks so much for coming on, telling your story. Really appreciate it, and good luck in the future.
Cheers, Chris. It's been great. Thank you.
Thank you. Thanks for watching. I'd love to hear from you in the comments. And if you could, give us a like, think about subscribing, and I will see you in the next one.